Okay, so this is chapter 4, number 19, 21, and 24. And again, you guys should be trying these first and then watching the video to get help on them. So 19, this is a good introduction to statics, meaning that it's not accelerating, this thing is in equilibrium. So in order to solve this, we're going to break this up into two directions, the x direction and the y direction. So in order to solve, I'm going to use Newton's second law, F equals ma. The summation of the forces is equal to mass times acceleration. Since I'm going in the x direction, I'm going to put this subnotation x. And since it's not accelerating, I can just set this whole thing to 0. Okay, so on finding the x direction, well, to find out what my x direction tension is, I need to use a little bit of trig. So if I have this tension T1, well, if I have T1, to find the x direction, this component, then I need to use cosine and a little bit of geometry. If this angle is 60 and these are both horizontal, then this angle is also 60. Can't really see that. So this angle is 60. So that means that in order to find the component in the x direction, I'm going to have T1 cosine is 60. And since it goes to the left, I'm going to put a negative sign there. And then my T2, same explanation, that I'm finding the horizontal component. So to find that one, it's T2 cosine of 30. So if this angle is 30 degrees, this is my adjacent side, I get T2 cosine of 30. So if I use a little bit of trig here, cosine of 60 degrees is 1/2. Cosine of 30 degrees is square root of 3 over 2. So I can set this up, and with a little bit of algebra, I can isolate my T1 variable. So this is an equation that relates T1 and T2. But I can't solve for these because I only have one equation. So I need to come over here in the y direction and get my second equation in order to be able to solve. So again, in the y direction, I'm doing the summation of my f of y is equal to my mass times acceleration, but it's static, so it's 0. So now I'm going to use the sine function, and I'll show you up here on this T2. So since sine is the opposite of my angle, so if that's 30 degrees, sine is opposite, then that's why I use the trig function of sine of 30 degrees. So now I have a second equation with T1 and T2. I can substitute this T1 value with the T2 in here into this T1, and then I can solve my for my two variables. So that's a little bit of algebra for you. Okay, the next one, 21. Now 21 was a blue problem, so blue problems are harder, but let's just go through piece by piece. So the givens, I'm given my mass, I'm given an acceleration, I'm trying to find what T1 and T2 are, and then the implied given is that we know that gravity is 9.8 meters a second squared. So again, I'm going to find an equation that relates these two. So let's look at T2 on the bottom here. So if I draw a little picture of this T2, the force going up, so this is for this mass, and then the force of gravity pulling it down. Well, the force of gravity is just your mass times your gravitational acceleration. So we just get mg. So when I sum my forces in the y direction and set it equal to mass times acceleration, I have positive T2, it's going up, minus mg, which is going down, and I have to set that equal to mass times acceleration. This one's not static now, so it is accelerating, so that's why I have to use the mass times acceleration. Okay, now in this case, I know all of these values, so I can actually solve for T2. So I'll come up with a value for T2. Now if I look at T1, so in this case, well, now this mass, it still has its weight, so its weight, force of gravity, is pulling it down, but it also has that tension due to the other mass, so it has that force pulling it down. And so now I can solve for what this force of T1 is going up. So I'm going to sum my forces in the y direction. So I have a positive T1, I have a negative mg, and negative T2, and I set that equal to my mass times acceleration. It's the same acceleration for both. And since I know T2, I can plug that in and I can solve for T1. And that will give me the answer for T1. Okay, now part B says, now if your tension 1 and tension 2, if it's a string that can only, or a rope that can only withstand 85 newtons of force, what's the acceleration that you would need in order to, or what's the maximum acceleration it can have before the strings break? So for this one, I need to come up with an equation where I can solve for A. And I know T1 and T2 now. So if you look at this equation right here, well, I already have it set up where T1 minus mg minus T2 is equal to mass times acceleration. We already came up with this equation that has T1 and T2 in it. So if I just substitute T1 and T2, if I put an 85 in there, well, I know my mass times gravity, like I can find that out. I can just do my mass times 9.8. And then I can find this out. I can solve for A now because I know T2, I know T1, I know M, so I can solve for A. And that will give you the maximum acceleration before the strings break. Okay, 24. 24 has something that's conceptually hard to visualize, but it's a kind of cool concept. It actually brings in Newton's third law, that for every action there's an equal opposite reaction. So we can try this with spring scales in class, but if you have this scenario right here where you have two masses with a pulley and they're pulling on a spring scale in the center, well, that means that it has a tension pulling from this side due to this mass and a tension pulling on this side due to this mass. And the masses are equal in this case. So if I sum my forces in the x direction and set them equal to 0 because it's static, I can see that my tension in my 1 has to be equal to my tension in 2. So that's every action has an equal opposite reaction force. So T1 has to be equal to T2. So to solve, I can just solve for any one of these tensions. So if I just look at this case here, well, T2 has to be equal to mg. And if you look at that, it's because you have mg pulling down, T going up. So if you said T minus mg is equal to 0, well then T equals mg. So my tension is just equal to my mass times gravity. So that gives me mass times gravity 5 times 9.8, and that will give me the tension that the spring scale reads. And so B, this scenario right here, gives you the same reading as this scenario here. If this mass is still 5 kilograms, you end up with the same exact reading. And again, that's for Newton's third law, and we can talk about that in class. Okay, so A and B are the same. And C, well, now you have two masses pulling it down. So in this case, since you have two masses pulling it down, if I look at this, this tension right here in this string, if I sum my forces in the y direction, I have a positive T going up. So that's the spring scale. I have a positive T. And I have now 2 mg going down. So T minus 2 mg is equal to 0 because it's not moving. So my T is equal to 2 mg. So double what this would be. Okay, the last one, this one's pretty tricky, and again, I think we'll have to go over this in class. But in this case, we have the mass is on an incline, so it's on a ramp, and the incline's at 30 degrees. So a trick that you can do for this, so we're trying to figure out what T is, but since T is at an angle, it makes it kind of hard. So I'm going to teach you this trick in class, but hopefully this is your, you'll get a first exposure to it right here. But if I have this scenario where T is at an angle, well, I can shift the whole thing. And so I'm going to shift it down 30 degrees. And if I shift that down, that shifts this over 30 degrees. And by doing that, now T is all in the x direction. So I only have to worry about the x direction here. So this is just the x direction. So now I can just sum the forces in the x direction and set it equal to 0 to solve for my T. And so now I'm looking for the x component. But the x component now, here we're using sine because if you look at this, this is the angle opposite, or this is the component opposite the angle. So opposite uses sine. So I'm going to have mg sine of 30, and since this is going to the left, I give it a negative, and then if T is positive, it's in the opposite direction. So then I can solve for T, and T is just going to be mg sine of 30. And again, this little trick just saves you a lot of trig, and so you don't have to sum in the x direction and the y direction. So we'll go over this trick again in class. Okay, so keep up with the work.